Today's session, we will be covering the vector lake. In the session, we will be also exploring how vector DBs actually work and how you can use vector lake as a vector DB and how it's simple to use. We will also providing you with a Google Colab notebook, which you can use and gain experience and get to know the tutorial how to use the vector lake. It's quite easy. First, we are going to dive deeper. What is vector DB and how does it work? Okay, so let's start. Yeah. So vector databases, these are a new database vertical which has grown in some years. These were introduced few years back, but these gain a lot of importance after the AI and ML, this whole technology started booming. So actually these databases are special databases in which the data is stored in the forms of vectors. These are numerical representations that can be used to find similar items quickly. So I hope you all have studied the concept of vectors in schools and colleges that we study. That they're vectors and in the form of they're long arrays of vectors that we store in these databases. So we convert these data into these vectors, and then they, as you know, there are concepts of dot product, vector, the cross product. We use some algorithms based on these and search on the basis of these algorithms. So how these vector databases actually work is that we know any actual vector database, any database actually has four main functions, which are storage, deletion, insertion, and retrieval. So when you see in vector databases, the storage works as first we convert the data into vector embeddings. These could be converted using any tool you have, like OpenAI provides you the embedding conversion of embedding tools, and many LLM provide these tools. You can use that to convert your data. You convert them into vector embeddings. Also, when you use Groclake now, vector lake for vector conversion, we also provide a tool. Just you have to write vector lake dot generate, and it will generate a vector for it. So you generate the embeddings for your data, then you store in the DB. And if you have stored in a DB, you may want to delete that vectors from the database. You may want to insert new data or maybe update that data. And the last process is retrieval. The retrieval is very important in vector databases because the retrieval is different in compared to a normal databases. Here, similarity search works. There are quite many algorithms that we will be showing you that you can study on your own because they are vast algorithms and they're quite important. These are important algorithms. Uh, they are nearest neighbor algorithms that help you search the nearest neighbor and the similar neighbor. Okay. Anybody has any doubt, he can ask. We can pause in between. If you have any doubt, just let me know. We'll pause and discuss about it. Yep. Okay. So what is the importance of vector DB? The vector DB is used in vast number of use cases. We use in visual search. We convert images into vectors. Once we convert these images into vectors, we can find similar images related to them. The only thing you have to convert a query also into vectors, then search for that. It will find this most relevant, most similar vector to that. We use in natural language search. So you know about semantic search. Have you ever observed actually how when you use OpenAI LLM or maybe any LLM you can take like this Gemini or anything, you write something. Maybe sometimes the spelling is wrong. Maybe the data sometimes is irrelevant, but you get the correct output. Have you ever thought how does that work? It's all working on this natural language processing NLP that we also covered in previous sessions. Actually, what happens is that when you type a query, it's also converted into vectors. They used a whole process of NLP, natural language processing, where they convert your query into meaningful sense that they compare it thousands of more data they have, maybe some queries, the data they have, then compare and get the right result which they have to get the right result. So it's used in the natural language search, like in the OpenAI, LLM, and everything. They use vector DBs definitely, and especially a very vast use case that has been come in few years is the recommenders. Have you ever thought that how Amazon recommends you the product related to the one you have searched? These all the things are based on vector DB. They use their metadata, they use their body everything and convert them into vectors and compare with different vectors to get to a similar vector or a product. After they get a similar vector, they give you the product. Anybody has any doubt, or should we proceed? Yep, we can proceed. Okay. So this is a quite a basic flow actually of how a vector data works. See, first I told you have any data. Let's say I have a query, what is the capital of India? Maybe show me a green t-shirt of size 42 or something, anything like that's a data. You use embedding models. These embedding models are provided by many LLMs and everything. Different LLMs provide these embedding models. So we have different embedding models. Then we convert them into vector embeddings. You take your data, embedding model converts them to vector embeddings. After the data is converted into vector embeddings, we store them, or you can say index them in the vector databases. Now these are huge databases. You have to index them because you have to get them searched. So first you have to index them definitely. Once it's indexed in the vector databases, now you can connect your user application and search from them. They have a vast user case. We will seeing how what use case they have. The main use case that you will be covering in this hackathon is definitely for building RAG applications and building agentic RAG applications. So we have already covered data lake. We have already covered model lake, catalog lake. So this is the last tool that we are covering. So definitely you can, after this, use VectorLake and complete your agentic RAG application. Yep. So this is the proper flow, how the vector DB actually works in a RAG model. So you don't actually have to worry that you have to implement so many tools. Actually, when you're using Vector Lake, these all tools get covered inside the vector data lake only. So you don't have to worry. You just have to create this application. We all know that we have covered this in the data lake document, how we can convert this. So this part is already covered by data lake and this is vector lake. So how it actually works, let's see. So you convert your data into embeddings using an embedding model. You query it into through API gateway. Just leave load balancer. This is not load balancer is usually used to divert the traffic equally so that the tools can be used properly. Okay. Then actually what happens inside is that this already like I told you in the past that they convert to vector embeddings, this index into vector databases. Now the query which has been generated, it will be compared with the last amount of set of vectors that have been already there in the vector databases. They will be compared, the vectors will be compared and give you the right vector which is the most related. Now you can also rank these vectors. See, I want a top 5 most related vectors. So I get a first, second, third, and you can also get a score for that. Maybe 0.98 is the most relevant vector that's related to your query. This is how they are using the recommendation. The Netflix, when you search, when you use Netflix, usually you get recommendation that you should watch next series this, next movie this. How these works? These all works on something concept of vectors. So main use case of vectors you can understand is the similarity search. You search between the similar vectors. The important thing is that how you convert your data into vectors, that's already been provided. So you don't have to worry about that. That's provided through Vector Lake and other LLMs also provide that. So inside there's a complicated task that all happens that the vectors will be stored according to the indexing will be there. They will be searched based on the similarity, the algorithms that have been there. You can study about these algorithms, nearest neighbor search algorithm. There are many algorithms for this. There are many research papers also have been written. You can also study about them. So let's see. So today we will be showing you a small tutorial that we have created in the Google Colab. We will be diving how to use this vector lake. This is a small tutorial that you can use to create your own tools, your own RAG, agentic RAG application. So let's dive into this. So already we knew few steps, like just we have to install the Groclake library. Yeah, the Groclake library installed. Then we initialize, set up the environment variables. Then we create a new vector instance. So we created a new vector instance and created a new vector. So what do I mean by creating a new vector? I'm creating a small space inside the vector lake so that I can use this to store my for all the data. So actually, what will be the real flow? First, you will be storing your data into data lake that we already covered in the previous section, how you have to use data lake. If you have not already seen that, you can see that session already on the YouTube. We have uploaded that. So first you store your data on the data lake, then you chunk your data actually. You send those chunk of data into vector lake. They will first convert into vector embeddings. Uh, and first you will create a space in the vector lake that we created vector create. Then we will create vector embeddings for your data for each chunk of vector embedding. Okay. Now see, I generate a vector representation. So this is a simple tutorial how we are showing you. For red shoe size 10, generate me a vector embedding. Generate, see this simple function that you have to vector dot generate query. So see, it's generated a vector for this. So I already told you there are long vectors of arrays. If you go, this is a very long vector. For just a small query, it generated such a large vector because it has to do a lot of work using that similarity search and all. So I generated this vector for this. Red shoe size 10. Now I have to also store this. So I generated a space using vector.create. I generated a space. I generated a vector for this. Now I will store in that space. I will store this vector. So what I will write a payload for that. This is my payload. The generated vector is the red shoe size 10 vector generated. The vector lake ID that I got from here. And then the document text, red shoe size 10. I just, usually your text is long, but this was so small that I just document text means like a title for that. Vector type, this is a text type. You can have images, you can have different type of data. You can have, then you write a metadata. For each product, you may have different metadata. So may the price is 100 for this shoe. I've written the color is red, the size is 10. This helps in the more better similarity search. Now I'm just printing the payload because I want to check the document is going correctly, and then the vector dot push I will run, and this will send the vector into the database. So see, it gave me an ID, means my vector is properly stored in the vector database. The space that was created for me has properly stored that vector in the vector database. Now what you have to do now, if you're creating some application, you will write an API, maybe an endpoint to call that data from the database. So you have to write a search query for that. How will you write? So already I told you vector database, if I have to search the same query, that will be not of any benefit. What's the best benefit is the similarity search. Now maybe user ever comes like on Amazon, maybe user never comes and say, show me the exact model of the shoe. He will always write like blue Nike shoes, red Nike shoes, something like that. And if I write that, I have to show him this shoe. For example, if a user says red shoe for men size 10, he mentioned a long query and he wanted a shoe which is of size 10. He did not mention color price, but we only have this in the database. So we should get this as an output. If we had many more shoes of maybe size 100 or something, only shoes, then it should also come, but at a later stage. The ones which is the most related, it should come. Right now, only we have this query. So it which is related to our query red shoe of men size 10. So we'll get this as an output. All right. So let me search. This is my search payload and I search this. So see, I get red shoe size 10. I got this two times. There's a reason for this because I pushed once more before the session. So there's twice the actually the red shoe size 10 is stored twice in the database. That's why it's giving me as these two as the top two most relevant queries. So if you see my query was red shoe for men size 10, I generated a vector for this first. Then I did a write a search payload for this and I searched this vector. So it run the whole in the database as well as the these algorithms that we will be seeing. So it returned me the most relevant vector which was there using the similarity search. I got a similar most similar vector this which was red shoe 10, which was the most relevant vector. That was my result. And you can see the price of 100 color red, and you can just take this all data and use in your front end or application that you're creating. This is how you can create a proper vector lake endpoint actually instance for your application. This was a small tutorial. We will be sharing this Google Colab notebook with you. You can use that. Now coming back to the session. Yep, let's come back. So we are coming to end of the session actually. So VectorLake, what's the specialty is that it's the ease of use. There are many more tools that you can use for vector databases usually, but the best thing is that the Vector Lake is so easy to use that you can just create a full application using Data Lake, Vector Lake, and Model Lake. The catalog is different because when you are not you creating for an e-commerce or maybe related to that image something, that's not always required. But they're so easy to use that you can just create a whole RAG agentic RAG application in just an hour. So there are many famous vector databases. Usually we have Pinecone, Milvus, Chroma. So these also work similarly. They are properly same, just some are more complex, some are more easy. The vector lake I would seriously say is one of the most easy to use and the same efficiency you will get using any other tool. So there's some algorithms study for vector DB. These are the algorithms that are usually used for similarity search that I told you. Approximate nearest neighbor algorithm. The techniques for this is there are many techniques. There more algorithms are there. Navigable, small world, locality sensitive hashing, and KD trees. You can learn about more about these algorithms and things because these are quite complex. You have to read a lot of research papers. But if you have interest, definitely these are a lot of beneficial. You can dive into them. So coming to end, we just want to tell you one thing that today was the last session of all the tools that we conducted. We have already conducted for the vector lake, catalog lake, data lake. This was last session. We have already uploaded all the sessions. This will be also uploaded on the YouTube. So from tomorrow, we will try to focus on creating a full RAG application in the one session because it does not take much time. We will creating that only Google Colab that we'll be always sharing with you. Then you can get to know how easy to create a RAG application using the Groclake. After that, you can create and just you have to connect it with your front end and your whole application will be ready. You can definitely enhance it using more tools which are not in the Groclake. One user you recently in the hackathon was saying that he wants to connect OCR technology in the Python. They have OCR and all, so you can use these also and research more. If you have any questions, we are always open. We can answer them. For today's session, this was all. If you have any queries, we are free and to answer. Just let us